So the 13th question is from linear algebra. Um so it's based on matrices and the uh, number of solutions for equations basically. So we'll start with what information we have gotten in the question. So they say that the sum of the elements in each row of a matrix capital A. So A is a square matrix of order n, right? So we get that piece of information from this. And the sum of elements in each row is 1, right? So I will consider a new matrix that is not mentioned in the question to solve this. So I will say L is a matrix of ones, right? So it's a column matrix of elements which are all ones. So I will write like this: 1 1 1 dot 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 1. Okay, and it is of the same order to be multiplied with A. So it's n rows and one column, n by 1, right? So now this L I have considered, okay, and now what I will do is I will go to the given expression for B, right? So B is given to be a cube minus 2a square plus a. Oh, and before that, they have also mentioned that the sum of elements in each row is 1, right? So, from this matrix, from this L that we have considered, we can write this statement as A L equals L. Why? Because, say, consider n as 2, okay? So, you have 4 elements here. Say you have A, B, C, D, okay? So in this case n equals 2, right? And your L here will be 1 comma 1, right? And now if we multiply these two, what will happen? So this and this, so you will have A plus B, and you will have C plus D here, right? And according to the question, according to this statement, it said that the sum of elements in each row of A is 1. So which means this A plus B will become 1 and this C plus D will become 1, and you will get 1 comma 1, which is the same as what we considered here, right? This thing. So this is also 1 comma 1, this is also 1 comma 1, and this is L basically that we had taken for this example. So we can obviously write AL equals L. Okay, that's what I've done here. I'll erase all this. And I will call this as 1. Okay, now we factorize the RHS for this equation, right? So it becomes B equals A times of A square minus 2A plus I, right? And this basically is A minus I whole square, right? Because I square is the same as I, and the minus 2AI part will just become minus 2A. So it is A times of A minus I whole square. Okay, so I'll say from 1 AL minus L, which is equal to A minus I times of L, which is equal to L minus L equals 0, right? Because AL is the same as L, And the thing that we are taking away from this is that a minus I times of L equals 0. Okay, and now what we come to is, since this has a minus I whole square, uh, so we consider to check for BL, right? What is BL? BL is equal to a times of a minus I whole square times of L, right? Which equals a times of a minus I times of a minus I times of L. And this result, basically this result from 2, we write from 2 BL equals a times of a minus I times of 0. So which implies BL equals 0, right? So basically from this what we have gotten, a solution for the equation bx equals 0, right, where x is L. So that's why we had considered BL here. So we are trying to find the number of solutions or the nature of the solutions for bx, right? That is what the question is asking. So this basically solves it. BL equals 0. So we know that for any like for a homogeneous system bx equals 0, there always exists a trivial solution x equals 0, right? That solution satisfies this equation, and it's called the trivial solution. So but we have also found this non-trivial solution x equals L, right? Non-trivial. And what does this mean? So this, which represents the null space of B, is non-trivial, right? So if the null space is non-trivial, then the equation Bx equals 0 has infinitely many solutions. Why? Because if you consider any scalar multiple of L, right, some lambda L, this lambda L will also satisfy this equation, basically. So you can try that as a example. But yeah, since we have this non-trivial solution x equals L for this homogeneous system, we can conclude that Bx equals 0 has infinitely many solutions, and hence the answer to question number 13 is C.